Hi everyone, in this video we're going to be looking at the idea of standard deviation. So standard deviation for us and for everyone is going to tell us the spread of a data set. So right here the word spread. Now we so far have talked about how to find or discuss the center of a set of data, right? The mean, this was mean and median so far. Ones that we've done. So that's great. Got a set of data, help me find the middle, very informative. But we also need to talk about how the data spread out. Are all the data values and points really close together? Are they spread very far apart? We need a way to measure that. And so that's what we're going to talk about today. Now, just to kind of get you ready for this, there is one other way. Well, there's many other ways, but there's one other important way that you have seen spread measured before, and that's the range. So you've done the range before. Also an important way to measure spread. It's not the most useful, but still pretty important. And the way you do the range is you take the biggest number minus the smallest number that you have, and that's the range, the full range of values. But again, I could give you lots of different data sets, and you think about this a little bit. Lots of different sets of data that have the same range, but the real spread between the data points can be different. And so the range just doesn't quite do enough to describe spread to us. So while it's good, it's not enough. It only takes into account 2 of the data values. That can't be good enough. So instead, we are going to use something called the standard deviation, right? Now, I'm not going to make you calculate this by hand. There's a video on doing this stuff in Excel. You can see me do standard deviation in Excel, so you can check that out. But what we're going to do instead is just kind of talk about the idea of what it is. There is a formula for this, of course, but it's not very nice, so we're just not going to worry about it. Though you can look it up or come talk to me if you want. So in order to kind of understand this idea, we're going to look at this first example. Okay, so let's check out this first example here. So we've got 3 companies, Company A, Company B, and Company C. They each have 5 employees with 5 salaries. Okay, so there's an important line here. Let me scroll down a little bit more so you can see it. Okay, so if we're looking at this now, we see that okay, Company A, all the salaries are the same, right? So when you're just looking at this, this company seems to have, no real spread. The data points are all just the same. There's no spread, there's no difference between these salaries. Company B, on the other hand, well, there are some difference. There's some spread here, right? There's $40,000 between the person who makes the highest and the lowest, so that's a chunk of change. But besides that, the salaries are all pretty close to each other, right? So there's not too much distance between these salaries overall. Definitely more than here, but not that bad. Now, on the other hand, Company C, there is a lot of spread here. Lots of spread. So these are definitely spread out. We've got 2 people making close to $300,000, 1 person making $150,000, and then 2 people making $500,000. So these values are very spread out. Okay, so just something you can kind of think about, right? And that's because you already have this idea of standard deviation in your head. It's already there, but we need to kind of think a little more deeply about it. And we're going to talk about one way and kind of how we calculate it to give you an even better feel for how to use this when you're looking at numbers. A key component for doing the standard deviation is the mean. We need the mean to be able to calculate standard deviation. It's the basis of what we are going to do. So when I say spread going forward now, I can imagine how that can mean lots of different things. What we're going to be doing actually is when we calculate standard deviation, we take the mean of our data set, which in this case, because the problem's set up nicely, the mean here, let's do it in a different color here. So the mean here is actually the same for each of these companies. It's 150,000. So standard deviation specifically, what does it do? It takes every data point, each single data point, and it measures how far each data point, in this case each income, is from the mean. So let's kind of think through that. Again, I'm not going to have you do this formula, but we could think through it. 150,000. How far are you from the mean of 150,000? Well, 0. 0, 0, 0, 0. No spread at all. There's no spread because there's 0 difference between each data point in the middle. Here, well, we're 20,000 away. 10,000. This is the mean. 10,000, 20,000. Okay, so you see those numbers. They're not too big, but you know, there's some difference. And then this one, 145,000 or 500. 149,000, sorry. 149,000 plus 149,000. Here too, big jump, right? So this is again over 100,000, 149,000, 149,000 away from the middle. Huge jumps from the mean to each of those data points. So what we end up doing for the standard deviation is we take each of those differences, data point to middle, data point to middle, data point to middle, and in essence, we average them. It's a little more than that, but that's the idea. So basically all you're doing is you can think about this visually. You spread out all your data points, find the mean, and look at how far each point is, keep track of that, and then average those together. That's your standard deviation. About. There's a little bit more to it, but that's the idea. So these points are all pretty far from the mean, so I'm adding up bigger and bigger numbers and averaging them. We just talked about that. That will make the standard deviation, the average of all those big distances I've measured, bigger. And that's a key component for the standard deviation. If this is bigger, that's telling you more spread. This is critically important, okay? The bigger the standard deviation, the more spread out you are. Very important. Because it's just looking at all of the differences between data point and middle. Just think about it, if all the points are near the middle, then when I calculate all of those differences, I'm going to get small numbers because everything's close together. If points are spread out far, I'm going to get big numbers in that calculation, and I'm going to get a big standard deviation. So you've got to hold on to that very important idea. All right? So this is the idea. Now, the calculations for standard deviation are talked about below. This is something, again, do in Excel. It's not too bad. You just throw your numbers into Excel. You type in the standard deviation formula in Excel, which I show you on the Excel video, so you have it there. And then, boom, boom. Just like mean, just like median, pretty similar setup, okay? But what you're going to need to do is think about the number you get. Now, that number is actually going to be crazy useful in just a little bit. Not in this video, in this section, but in the next one. Like crazy useful. But for now, you don't need to look at the number and be like, yeah, but I know what that means exactly. No. You need to be able to think about that number and try to start thinking about what that tells you about your data being spread out far or not spread out. That's what I need you thinking about. So that's the idea of standard deviation. The average of the distances from data point to middle. Okay? So, let's look at a new example here. So, Bob conducts a study where he randomly selects 200 people at the mall and finds out their income. Tina goes to 200 random vascular surgeons in New York and finds out their income. So, this is another example where I'm not giving you the numbers, right? I'm just up here. I'm not giving you the numbers. I'm just giving you the setup, the people, and what you're measuring. And you've got to think about it. So specifically, Bob is right here, and he's got people at the mall. Tina has got surgeons. Okay, so that's what you got to make the connection. We are measuring income. So, the gears got to start going right now. Income for people at the mall. Income for surgeons. And we got to get that statistics brain starting to go, right? Those gears starting to go. You're starting to think about, like, what does that look like, right? I'm trying to think about, okay, surgeons, what do I know about their incomes, right? Doctors in general, surgeons. People at the mall. Who goes to the mall, right? That's hard to kind of pin down. I don't know what their jobs are. Could be kind of jobs, any kind of job. Surgeons, people with no jobs. Anybody could be at the mall. That's the kind of thing you just start talking out loud. Like, that's literally what I'm doing. I was just talking out loud about these things. So that's what you got to start doing, just thinking about it. Then you take a little time to do that. Start reading what the problem says. Which study would most likely have the highest mean? So average. Who's going to have the higher average? The people at the mall, the income for the people at the mall, or the surgeons? Well, think about it a little bit. Surgeons make a lot of money in general, right? They went through all that school. It's a high-paying job. So if I take surgeons and I look at their incomes, I'm going to get a lot of big numbers. So when I average, that's going to be big. Well, if I go to the mall, I could find surgeons. Surgeons, I'm sure, go to the mall, so I might get some high numbers. But I go to the mall, so my income's going to be there, and it's not the income of a surgeon. So there's me in there too. You're going to go there and you're going to have teenagers who might have a part-time job, might not. Their income or lack thereof will be in your calculation. So you've got this group of people who have incomes that are kind of all over the place, but more specifically, some will be lower. Well, you add up lower numbers plus maybe some higher numbers, your average will be lower than adding up just a bunch of big numbers for the surgeons. So, Tina's sample of the surgeons will have the highest mean because they make a lot of money. Done. Right? That's what you got to be thinking about. You got to be thinking about the people, who goes there. And you're not, remember, we're just trying to think generally about each group. What's generally true about them? It's totally true. Billionaire could go to the mall, and being a billionaire doesn't mean your income is that high, but someone with a very high income, higher than a surgeon, can be at the mall. But you're also going to have lots of people, and it's 200 we're talking about, whose income's much lower, and so you got to kind of think about what's going to happen in general. So which data set's going to have the highest standard deviation? Spread. Who's going to have the higher spread here? Well, the surgeons make different amounts of money, of course, right? Not everyone probably makes the same, but most of them are going to make a pretty high number. Bob, on the other hand, he goes to the mall. You got some surgeons there maybe making a lot. You got some people, teenagers, people without jobs, people who don't make that much money. You got them there at the mall too. That's a spread. That's a larger spread of incomes. And because the mall has a variety of people and a variety of incomes, that's going to be the largest spread, right? Another word for that that's used in this sentence that maybe might help you, but don't worry too much about if you're not comfortable with it, is variation. There's more variation, variety, right? That's the key word here, variation, variety of incomes. Some low, some high, some middle. It's all over the place. So you don't need the data to think about that. You can just think about it. Okay. So example 3 says, the lengths of the first 20 words in the foreword written by Tennessee Williams in Cat on a Hot Tin Roof are listed. All right. And the lengths of the first 20 words in Cat in the Hat by Dr. Seuss are listed here. So this is just, each one of these represents the length of a word. So Cat in the Hat, lots of short words, children's book. Cat on a Hot Tin Roof, not a children's book, bigger words. So just stop here. Think about our ideas here. Think about the center, the mean, the average of these. Think about the spread. Okay, so A says, the mean of this first one, the roof words, is 3.9. The mean of the Cat in the Hat is 3.1. Write a sentence that explains to a common person the real-world meaning of the fact that the mean of the Williams data, this first one, is higher. So just talk to me about what this means. I've got two data sets. This one, this data set, this first one here, right? This first data set here has this average. This one has this average. What does that mean? What does the 3.9, the 3.1 mean? Well, you could say a lot of things here, but specifically, you should tell the person what this number actually means, right? So the solution here says this means that the words in Cat on a Hot Tin Roof have an average length of 3.9 letters, or have an average of 3.9 letters in them. About 4. So the average word in this collection have about 4 words in them. People can connect with that. Oh yeah, 4-letter words, okay. But that's the average, not all of them, just the average. Cat in the Hat, on the other hand, has an average that's about 3, a little over 3. So, okay, yep. Cat and Hat. Look at that. Those both have 3 in it. Okay, I get it. So, the only other piece that's useful here, though, is noticing the difference. 3.9, 3.1. This tells the person that in general the words in this first book are bigger than the words here. Not all of them, right? Look, I've got a 2 and a 3 here. So it's not true for every single word, but in general, on average, bigger words, smaller words. That's what being able to have those numbers lets you do. So the next piece says the standard deviation is 2.6 for this first one. The spread is 2.6. The standard deviation of the next one, the Cat in the Hat, is 0.9. Tell me what that means. Well, what did we say? 2.6. This is bigger than 0.9, right? It's bigger. What did bigger mean? Bigger tells me more spread. That's it. So when you tell this person these two numbers, or they look at these two numbers, and you could think they're asking you, like, what does this mean? A bigger standard deviation means more spread. The lengths of the words are more spread out in this first book. So then you can tell them, like, okay, the 2.6 means compared to the 0.9. Again, we're comparing. Means that this book has more spread, which I think if you just look at the numbers isn't too terrible to see, right? You've got some smaller words in here versus some pretty big words in here. And so there's some clear spread going on. But if you look at Cat in the Hat, not really, right? Look, I got some 3s, some 2s, some 3s, some 2s. I got a 4. Okay, I even got a 5. But that's not really that far from 3 and 4 and 3 and 2. They're very similar. So that's it. That's what these are saying, right? These words are all similar in size, right? These words, there's more spread, more deviation, variety. And that's represented by this first number, the standard deviation, being bigger for this group, smaller for this group. So we can use numbers to represent that idea of spread or of not spread. Okay? And so there you go. That's the idea. So you can kind of read through this and dig in a little bit more, but that's just the general idea. And that's really the idea of standard deviation. This is what you need to be thinking about. It's spread. Now, more specifically, it's not just spread high to low. It's spread, take the data points. If you want to be more technical, but that can be helpful, take the data points, compare each point to the mean, and we're going to average that up. So again, you're really taking each point here, comparing to the middle. That's critically important with standard deviation. A lot of times you can just look and see that something's more spread out. But if you're having trouble with that, follow the idea, right? You can even do like a quick little type of calculation for yourself where you nail down the middle, the mean, and you just average up the differences here. 20,000, 10,000, 0, 10,000, 20,000. What does it look like to average those? Okay, I got some number. Okay, that gives me an idea. Over here, over 40,000, 140,000, 0, over 140,000, 140,000. Whoa, I'm going to add up all those big numbers. That's going to give me a bigger standard deviation. Boom. So you don't need to do the calculation exactly, but you can even dig into the numbers a little with that kind of approximate calculation that we were just doing. It's not perfect, it's not exactly what this formula will be, but it does a pretty good job giving you an idea. So that's it. Think through that. Check out the homework. You can see the calculations in the computer homework, but also start looking at the written homework because that's got some ideas where you're really trying to think about the idea of standard deviation spread, what it means, what that looks like, comparing different groups, their spreads, trying to kind of think things through. So give that a shot. Let me know